Hello students, hope you are having very informative sessions on different aspects of pharmaceutical packaging. I am Dr. Sanju Nanda and I shall be discussing with you the topic of liquid and solid filling machineries used in pharmaceutical industry. This will also include various principles of filling and capping oral, topical and sterile pharmaceutical liquids and solids. The initial lecture will comprise of liquid filling machines and the latter section will contain the solid filling and capping machineries. As you all know that all liquid pharmaceutical formulations are not of same viscosity and hence you can now understand that the choice of selection of a particular filling machine will take into consideration the quantity and viscosity of liquid formulations. This class shall therefore focus on various filling and capping machineries. Let's start our episode while taking a look at what we are going to learn today. Module 1 will comprise of the introduction. Module 2 will talk about filling technologies. In Module 3, we'll see the types of liquid filling machineries. In Module 4, we'll see the types of solid filling machineries. The capping machineries will be considered in Module 5 and will conclude the modules in Module 6. Module 1. The Introduction. A pharmaceutical formulation at an industrial scale is prepared at one location and transferred to another location for filling and packaging before releasing for distribution. Filling machines are one of the packaging machinery which package all kinds of material such as liquid, gas, paste and powder. The following basic elements of the filling process are the same for glass bottles and jars. That is, loading the bottles onto a feed or reservoir table, followed by feeding the bottles onto a track which aligns them and carries them through subsequent steps, then removing loose foreign matter from inside the bottles, followed by filling the bottles as they pass under a nozzle or tube, then applying a closure system and attaching a label, finally cartooning singly or in groups. According to the different filling materials, filling machines can be divided into powder filling machine, gas filling machine, paste filling machine and liquid filling machines. According to the degree of automation, these machines can be further divided into automatic filling machines, semi-automatic filling machines and fully automatic filling machines. Since automatic filling machines produce high output, these machines are used as a first choice. They may use a number of different filling principles to get the product into the bottle. Figure 1 shows bottle filling machine. However, it is surprising to note that no one type of filling machine can handle all liquids in all industries. For example, a machine that fills bottled water cannot fill cosmetic cold cream. Nor would a chemical duty filler can be used to fill pharmaceutical grade or dairy products. Although there are many different types of filling technologies, there are relatively few that are versatile, practical and cost-effective to own and operate. The choice of filling machine depends on the range of viscosities, temperature, chemical compatibility, particulate size, foam characteristics and hazardous environment conditions. Figure 2 shows an automatic liquid filling and capping machine. Now we are going to start the module 2. It comprises of the filling technology. Dear students, let us now try to understand the technology behind filling of liquids. The specific method used for filling a pharmaceutical liquid varies and greatly depends on the characteristic nature of the liquid to be filled, the type of container into which the liquid is to be packaged, as well as the required production output. Broadly speaking, filling can be divided into two main technologies, volumetric and gravimetric. This means that the desired quantity is either measured by volume or by weight. The choice of the filling method may be dependent on different factors like product properties. When the liquid product contains air bubbles, the normally preferred volumetric filling is then not recommended. Then desired volumes is one of the attributes. In case where the volume to be filled is about 20 liters, a gravimetric filling is preferred. It also depends on the available budget. When it comes to cost effectiveness, gravimetric filling is generally considered to be more expensive. Now it's time to discuss them one by one. Let's first understand the principle behind volumetric filling machines. Volumetric filling is usually accomplished by positive displacement piston action. Volumetric filling machines are based on a self-priming cylinder. Each filling station is equipped with a measuring piston and cylinder. A piston is moving inside the cylinder and the stroke length and diameter of the piston determines the filling volume. The fill amount is measured by the stroke of the piston. The fill accuracy is controlled by the close tolerances to which the pistons and cylinders are manufactured. Major changes in fill amount usually necessitate changing the piston and cylinder assembly. Figure 3 shows volumetric filling principle. There are two types of piston fillers that are available. They are check valve and rotary valve piston fillers. We'll first discuss check valve piston filling machines. A check valve piston filler works on a check valve principle that opens the in-feed valve on the draw stroke, then forces the draw side check valve closed while opening the discharge valve on the dispense stroke. These are good for very low viscosity liquids. We can see this in figure 4. Rotary valve piston fillers. These are ideal for filling very thick liquids and pastes. In this type of filling, the hopper feeds the rotary valve which connects between the hopper and cylinder on the draw stroke and then flips 90 degrees between the cylinder and discharge tube on the dispense stroke. Next is the gravimetric filling machines. In this type of system, filling occurs by dropping. When the filling level set inside the container is reached, the product in excess returns to the chamber. Because these machines weigh the exact weight using a valve that is placed over an electronic scale, the scale in combination with the weighing program controls the valve operation, resulting in a weighing process. We are now going to study liquid filling machines in Module 3. Another way of classifying the way liquid filling machines work is based on the type of pressure used while filling. For example, either ordinary pressure liquid filling machine or vacuum liquid filling machine and pressure liquid filling machines. Ordinary pressure liquid filling machine adopts gravity flowing filling based on its own weight of the liquid. Vacuum liquid filling machine is proceeding when the pressure of the bottle is below the atmospheric pressure. With simple structure and high efficiency, this kind of filling machine is usually used for high viscosity liquids such as oil, syrup, etc. Pressure liquid filling machine works when it is above the atmospheric pressure, which can be classified into two parts. One is called equal air pressure filling, which means the liquid flows into the bottle based on its own weight when the pressure of the liquid reservoir is equal to the one of the bottle. The other is called high pressure filling, which means the liquid flows into the bottle based on the pressure difference when the pressure of the liquid reservoir is high than the one of the bottle. Dear students, we shall now study the principles and working of some of the filling machines which are used industrially. For example, piston filling machine, overflow filling machine, peristaltic filling machine, and servo-positive displacement filling machine, time gravity filling machine, net weigh liquid filling machine. Piston filling principle has already been discussed above and we shall study the others. We start with overflow filling machine. Overflow fillers are the machine of choice in handling very foamy products at higher speeds. The figure here shows the supply side, that is the dark blue of a two-part nozzle which is used to pump the product into the container. When the container fills up to the target fill height, the excess product and the foam is forced out of the container, that is the red arrows, via the return side to the original product source tank. Figure 5 shows overflow filling machine. This type of filler is best suited for liquids with low to medium viscosity. Liquids with solid particulates when below the size of 1 by 16 inches can also be filled. Peristaltic liquid filling machines will be discussed now. Peristaltic liquid machines are the machines of choice for the high value, small volume fills at very high accuracy. It is primarily suited for aqueous and other light viscosity products. Examples of products filled on this machine are sterile and pharmaceutical preparations, fragrances, essential oils, reagents, inks, dyes, and specialty chemicals. The unique advantage of this machine is that the only fluid path is surgical tubing. The fluid path is disposable, easy to clean up, and eliminates cross-contamination problems. Accuracies of 0.5% are achievable for fill volumes less than 1 ml. Figure 6 shows the peristaltic filler machines. The peristaltic pump makes intermittent contact on only the outside of the surgical tubing so that the product only touches the inside of the tubing. The filler's master computer independently tracks the number of rotations of the peristaltic pump head so that it knows precisely how much product has been delivered. When the target fill volume is reached, the pump stops and the remaining product fluid do not drop out due to pipette action. The computer stores all fill parameters in memory for fast changeovers. Next is the servo-positive displacement filling machine. This is a very versatile filling machine capable of filling nearly any type of product that can be pumped. Each nozzle has a dedicated servo-controlled pump that can deliver thin liquids, medium and thick viscosity liquids, and liquids with large particulates. Examples of the range of products that can be run on this machine include soaps, pharmaceutical products, oils and greases, cosmetics, etc. Figure 7 shows servo-positive displacement filling machine. The next in the line is the time gravity liquid filling machines. These are the most economical type of filling machines for a limited range of applications. This filler is best suited for liquids with very thin viscosities that do not change with ambient temperature or with batch variation. This machine is also suited for applications where recirculation of the liquid in the fluid path is not desirable. The machine works by a simple principle in which the amount of liquid flowing through a fluid path will always be the same for a fixed amount of time. Initially, the bulk liquid is pumped into a holding tank above a set of pneumatically operated valves. Each valve is independently timed by the filler's master computer so that precise amounts of liquid will flow by gravity into the container. Independent timing of each filling valve or nozzle corrects for minor variations in flow rates so that each container is filled accurately. Please see figure 8 for time gravity liquid filling machine. Examples of products that can be filled by this machine includes water, solvents, alcohol, specialty chemicals, paint and inks. Although this type of filler is used predominantly on products that do not foam, foam may be limited and controlled by subsurface or bottom-up fill capability. The disadvantage of this type of technology is that the dynamics of the fluid path and nozzle actuation characteristics continuously change over time. This requires the operator to make adjustments to the machine's stored parameters more frequently than other technologies. Now we'll study about the net weigh liquid filling machines. This type of filler is best suited for liquids filled in bulk quantities, for example, 5-gallon pails, etc., or smaller quantity products that have a very high manufactured value. Oftentimes, there are products that must be sold by weight for commercial reasons, and therefore this filling machine is the only choice. Examples of this type of filler for bulk products include cleaning chemicals, enzyme solutions, oils, cosmetic creams, and other medium value products. High value products filled by these machines include specialty adhesives and paints, precious metals dissolved in acids, and other expensive specialty chemicals. Please see figure 9 for net weigh liquid filling machines. The operation of this type of filling machine is simple. The product bulk supply is pumped into a holding tank above a pneumatically operated valve. The valve opens and real-time net weight information is monitored until the target weight is achieved. The valve simply shuts when the target weight is achieved. The advantage of this filling machine over others is that it is sometimes the only practical type of filling for a limited range of applications and for large volume fills. It is also very accurate and effectively provides its own quality control, assuming the scale is functioning properly. However, the limitation of this type of filling machine is that it is relatively slow method of filling and costs more per filling. After studying the liquid filling machines, we are going to study about solid filling machines in Module 4. Solid pharmaceutical formulations include powders, granules, pellets, tablets, and capsules. For powders, it is difficult to attain an accurate fill weight since the flow is irregular. As a result of this, slight tolerances in the fill weight are permitted. For automated filling, granules are preferred since they flow freely. Control of the fill is generally accomplished by filling cavities which have been calibrated to deliver the desired weight of the product. For tablet filling, exact tablet count is achieved by highly versatile electronic or mechanical counting machines that can handle tablets and capsules over a range of sizes at rates up to 40,000 per minute by filling 7 containers at a time. They can be packaged into strips, blisters, separately and independently. Validation for each of the critical steps should be carried out. In the present module, solid filling and capping of bottles shall be touched upon. Let's first see powder in a bottle. During drug approval process, when clinical trials are going on, it is not uncommon to fill individual doses of API into glass or plastic bottles. These doses are then reconstituted in the clinic or by the patient by adding water or some other solvent system and administered to the patient. Figure 10 shows manual powder filling. There are various types of materials from which containers and closures are made. Now you will see some containers and closures and the machineries used for automated filling and sealing. Figure 11 shows some capping machineries in action. Module 5 Capping Machineries. Figure 12 shows a CGMP-based bottle packing and capping machinery. Dear students, you can now see some commercially available automatic powder filling and capping machine. The machinery shown now is an automatic powder filling and capping machine and has the following conspicuous features. Number 1. Main frame and working table is covered by stainless steel panels. Number 2. All materials in contact with the product are made of 316L stainless steel. Number 3. Vials in feed and outfeed flow is controlled by 2 motorized star wheels, both inclusive of mechanical clutch with dedicated safety sensor to stop the machine. Number 4. The working stations are able to handle 2 vials at a time. Number 5. When small dosages are required, only 2 dosing pumps and needles are involved. Number 6. Easy and quick changeover with parameters managed by the PC. Number 7. Vials capping executed by one robot, therefore there is no need of size changes. Figure 13 shows an automated vial filling and capping machine. Some salient features of the depicted automatic capping machine is the precision with which it is built on a strongly welded steel frame. Doors are provided to facilitate the servicing of machine. Bottles are moved through a conveyor belt to an inferior star wheel, which brings the bottle below the sealing head. Before positioning the bottle under sealing head, a cap is placed on the bottle from the delivery chute. The body and the neck of the bottle are positioned below the rotating head, where the sealing head is performing perfect operation of threading and sealing. Specially designed hopper is provided for more storage capacity. Deliver cap to delivery chute with correct position that ensures the perfect position of the cap at the end of delivery chute. Figure 14. Automatic filling and capping machine suitable for filling and capping plastic and glass bottles. The filling and capping machine, which is being shown now, is a proprietary product and is specially designed for the pharmaceutical and cosmetic industry. Its special features are discussed here. It allows filling in one cycle by means of tracking nozzles. It is an ideal combination of continuous and intermittent motion. All the parts in contact with the product are made of 316L stainless steel. Wide range of operation options are available. Provision of easy and perfect cleaning of all parts. Now we conclude this module. Various liquid and solid filling machines were studied. They were based on various filling principles. Choosing the correct filling equipment can have a measurable effect on the efficacy and productivity of a packaging line. It can be concluded that no single filling machine can handle all liquids in all industries. For example, a machine that fills bottled water cannot fill cosmetic cold cream, nor would a chemical duty filler be used to fill pharmaceutical grade or dairy products. Although there are many different types of filling technologies, there are relatively few that are versatile, practical, and cost effective to own and operate. Automatic filling machines can use a number of different filling principles to get the product into the bottle. Each filling principle has its unique benefits or advantages. While more than one type of liquid filler may work for a given project, each project will ultimately have an ideal filling machine or filling principle for the job to be completed. The choice of filling machine depends on the range of viscosities, temperature, chemical compatibility, particulate size, foam characteristics, and hazardous environment conditions. Dear students, this brings us to the end of this episode of filling and packaging of pharmaceutical solids and liquids. Hope you all have had a good exposure of the packaging machinery. We shall be back again soon with one more episode of Pharmaceutical Packaging.